We're going to talk about using graphs to persuade. And what I mean by that is, think about if you're trying to persuade someone to your side of an argument. You could present something in a different way that would help give you the one-up. You could give an advantage to whatever your argument is based on whatever you showed them graphically. And so you could take the same information, present it two different ways, and it would seem like a totally different story. So to give you an example of that, I went through our Prentice Hall pre-algebra book and found a couple of different graphs that help demonstrate what I'm trying to show you. So if you were to look at this graph, which shows the populations of Chicago and Los Angeles, first glance you'd look at that and say, wow, the population of Los Angeles is way bigger than that of Chicago. I mean, it just looks overwhelmingly big. It looks probably 2.5 to 3 times the size. But there's a catch. Look really close at the y-axis right here, okay? Notice this little break? This little break means they skipped from 0 to 2.5 million. And that's an okay thing, you can do that. In graphs, you're allowed to actually do that if the space provides. But the catch is that can be misleading. So if you look at this right here, the population of Chicago is right about 2.7 million. And the population of Los Angeles is somewhere between 3.5 and 3.6. Now, 2 times the amount of Chicago would actually be more than that of Los Angeles. But this graph, if you were to say this is Chicago, double it, maybe 3 times as big, then you would say that's about Los Angeles. But if we took the actual number, 2.7 times 3, obviously we could tell is significantly larger than Los Angeles. So this graph is actually misleading. Yes, it's not lying because Los Angeles is still taller and Los Angeles does still have more people living in it than Chicago. But this graph is meant to make you think that Chicago is significantly less, or even almost close to 1/3 less than that of Los Angeles. So that is meant to persuade you into believing the population or the growth of Los Angeles is higher than that of Chicago. So let's do another example here using gas prices. If you look at these two graphs, one of them will make you think that the gas prices significantly changed much more than the other. One looks more gradual, doesn't it? Which one looks more steep? You should say that the one on the right, it looks much more dramatic. But there's a catch. These graphs are exactly the same. If you look closely, though, it's because the months are much closer together on the graph on the right, which makes it appear to climb more rapidly. That suggests that the prices are going up much faster than they actually were suggested by the graph on the left. Over here, we'd say, oh, the gas prices didn't increase by that much if you look at it from month to month. Over here, we'd say, whoa, big jump. Okay, so let's do this graph on pillowcases. Now, I know it's a funny example, but just run with it. What makes this graph misleading? If you look at our y, there is no break at the beginning, meaning that there was a big jump in the difference. So that's not there. The years, I mean, that's okay to be a few years apart. The catch is, look at this height and look at this height. The increase is probably somewhere around 1/3 to 1/4. But the width of this one, they made it twice as wide, which is going to visually make you think, oh, well, that one's much bigger. Now, granted, it is bigger, but is it as big as they make it seem? No, it doesn't seem so. So let's do one last one, and this graph is talking about milk sales. So what's your first impression when you look at this graph? You should think that by looking at it, that the milk sales from January to February looks like it quadrupled. Because, I mean, not only did it go up, which is not misleading, however, they made this thing so much wider. So when they made it twice as wide at least, maybe even 2 to 3 times the size, plus its height, it just gives the impression that it overall was massive increase. So just be wary when you look at graphs and say something like that. So if you could have redrawn this, you probably would have said, so that it doesn't look as big, you could have said, take this right here and shrink it back down at least to the same width, so that way we're not comparing 2 different sizes, and then just go in height. And lastly, in order to be a great person and cite my sources, this is the book I use to get all those images.